Hello students, today we are going to discuss about the circular motion, the topic of circular motion. One of the important topics in 11th and also IIT-JEE NEET. So what is circular motion? First of all, if you think about the motion we have different types of motion here. What are those? First one is translatory motion. Translatory motion. Second one, rotational motion. Rotational motion. Third one, oscillatory motion. Oscillatory motion. And then random motion. So these are the four types of motion. But where is the circular motion? So circular motion is the special case of rotational motion. Circular motion is the special case of rotational motion. So if you just think about translatory motion. What is translatory motion? The motion of a particle in a particular straight line in a particular direction. That's a translatory motion. Rotational motion means the motion of a particle about a fixed point is nothing but rotational motion. Oscillatory motion is the to and fro motion about a fixed point. And random motion means the motion of a particle without any particular direction. So now our topic is circular motion. That circular motion is the special case of rotational motion. Circular motion is the special case of rotational motion. So here if you see that circular motion, a particle or a body is rotates or revolves around a circular path or moving around a circular path. It's called simply circular motion. Means the particle is moving along the circumference of the circle or the particle is moving in a circular path. It's called simply circular motion. In the circular motion, first we have to going to discuss about the first point, angular displacement. Angular displacement. Angular displacement we can take as function theta. What is this angular displacement? For example, here I am considering a particle which is having some angle with the x-axis. So the particle P initially here, so this is making an angle theta 1, means this is called angular position. Angular position. At t is equal to 0. By the time changes, the position of the particle changes from theta 1 theta 2. This is the final position. Now the change in angular position, we can take as delta theta is equal to theta 2 minus theta 1. The change in angular position is called simply angular displacement. The change in angular position is called simply angular displacement. Here what is the change in position means? The particle is moving from here to here. That is theta 2 minus theta 1. The change in angular position is called simply angular displacement. If your particle is completing one rotation, for one rotation, the angular displacement is angular displacement is simply 2 pi, means which completing one complete angle, that's we can take as 2 pi, because the SI unit, if you are observing the angular displacement, we are taken as the SI unit radian. Angular displacement radian. So the one rotation theta is equal to 2 pi. For two rotations here, what about the angular displacement? For two rotations, the angular displacement is equal to 2 into 2 pi. For two rotations, angular displacement 2 into 2 pi, because two rotations, which is making 10 rotations. For 10 rotations, the angular displacement is goes to 10 into 2 pi. Angular displacement is goes to 10 into 2 pi. For n rotations, the angular displacement is goes to n into 2 pi. One rotation 2 pi, two rotations 2 into 2 pi, 10 rotations 10 into 2 pi, and n rotations n into 2 pi. Means this is simply we can call as angular displacement. Angular displacement is nothing but simply the change in angular position. Next we have angular velocity. Angular velocity. We are representing with letter omega. The angular velocity omega. Angular velocity means simply we can say that rate of change of angular displacement. The rate of change of angular displacement. We are also taken as average angular velocity or instantaneous angular velocity. Average means the total angular displacement upon total time. That's we are taken as average angular velocity. And instantaneous means at a particular instant of time. If you are taking instantaneous, that instantaneous you can able to take limit delta t tends to 0, delta theta by delta t. So then the angular velocity or the instantaneous angular velocity will be goes to simply d theta by dt, d theta by dt. If a particle is completing one rotation in 1 second, one rotation in 1 second, that 1 second is called time period. Then what about the angular velocity? Particle completing one rotation in 1 second. In 1 second. Then the angular velocity is goes to simply angular displacement how much? One rotation 2 pi. 1 second 1. So means simply how much angular displacement? Sorry, angular velocity 2 pi radian per second. 2 pi radian per second angular displacement. Next, in case if it is completing 2 rotations in 1 second, 2 rotations in 1 second, that is goes to 4 pi radian per second. And we are taking some live examples. Live examples means the angular velocity of the seconds hand. Angular velocity of seconds hand. Seconds hand. So the angular velocity of seconds hand. So means for angular velocity means one rotation, how much time is taken by the seconds hand? In watch we have minutes hand, seconds hand and as well as hours hand. So in that we can take for one rotation 2 pi angular displacement, but which takes how much time? 60 seconds. So that is equal to simply pi by 30 radian per second. Pi by 30 radian per second. This is also we can name as 1 RPM, means 1 revolution per minute. 1 RPM is equal to 1 revolution 2 pi per minute 60 seconds. So that is equal to simply pi by 30 radian per second. This is also unit here. Sometimes they may give 1 RPM. 1 revolution per minute is equal to pi by 30 radian per second. Next, angular velocity of minutes hand. Angular velocity of minutes hand. Minutes hand is nothing but for minutes hand how much time is taken to complete one rotation? 1 hour. 1 hour means how much time? 60 minutes. 60 minutes. 1 minute is 60 seconds. So that is equal to 2 pi by 3600. Nothing but pi upon 1800 radian per second. Pi upon 1800 radian per second. That is the angular velocity of minutes hand. Next we will take angular velocity of hours hand. Angular velocity of hours hand. For hours hand, the angular velocity should be hours hand. That is equal to 2 pi upon, for hours hand how much time is taken? 12 hours. 12 hours means 2 pi into 12 into 3600. Nothing but the value is 1 by 21600, sorry, pi by 21600 radian per second. This is the angular velocity of hours hand. And take about the angular velocity of earth. Angular velocity of earth. Earth can take for one rotation how much time is taken? For one rotation which can take 24 hours. 24 hours, nothing but 5 by 12 hours. 12 hours means 12 into 36. So that means the value is goes to 43200 radian per second. So this is the value of angular velocity of Earth. Angular velocity of seconds hand, angular velocity of minutes hand, angular velocity of hours hand, and angular velocity of the Earth. Okay, we'll take one small application based on this angular velocity. What is that application? Here I am considering two particles. Those two particles are moving in two different circular paths and different angular velocities, but in same direction. Then what about the angular velocity difference between them and also time difference between them? So here I am considering two circular paths. First circular path of radius r1 and second circular path of radius r2. Now here angular velocity is omega 1. Here angular velocity is omega 2. Then what is the time gap between the two particles? Time gap between the two particles. First of all, you can take the relative velocity, the relative angular velocity. The relative angular velocity, when both are having same direction, the relative angular velocity will be goes to omega 2 minus omega 1. If both are in the same direction, so omega 2 minus omega 1. If both are in opposite direction, then omega 1 plus omega 2. So see here, what is the time difference? For the time difference between the two particles is nothing but we can take 2 pi upon omega relative. So then 2 pi upon omega relative means omega 2 minus omega 1. What is the value of omega 1? Omega 1 is angular velocity of the first particle, that we can take 2 pi upon t1. T1 is nothing but time taken by the first particle to complete one rotational time period. And angular velocity of the second particle, 2 pi upon t2. So now if you are substituting both values, then t is equal to 2 pi upon omega 2 is 2 pi by t2 minus omega 1 2 pi by t1. Omega 1 2 pi by t1. You can take common 2 pi and cancel. After that 1 upon 1 by t2 minus 1 by t1. Take the LCM and then finally you are getting the value t is equal to t1 t2 upon t1 minus t2. t1 t2 upon t1 minus t2. That is the time difference between the time period difference between the two particles when those are moving on a concentric circular paths or else in a coplanar. Okay, let's in case same condition if both are moving in opposite directions. Both are moving in opposite directions. Let's see. First particle is moving like this. Sorry, second particle. And the first particle is moving like this. Omega 1 and as well as omega 2. Here circular path of radius r1, here circular path of radius r2. Now the relative angular velocity is equal to again omega 1 plus omega 2 because both are opposite to each other. So that's why omega 1 plus omega 2. So then what about the time difference between them? Again 2 pi upon angular velocity omega 1 plus omega 2. What is omega 1? Here already we wrote 2 pi by t1. What is omega 2? 2 pi by t2. If you are substituting there, then you can get finally the calculation t1 t2 upon t1 plus t2. t1 t2 upon t1 plus t2. This is simply we can take the angular, the time gap between the two particles. Both are moving with opposite angular velocities, opposite to each other and as well as in same direction. Next, we'll see about angular acceleration. Angular acceleration. Angular acceleration we are representing with letter alpha. Angular acceleration we are representing with letter alpha. The angular acceleration alpha is equal to, we can take the rate of change of angular velocity, delta omega by delta t. Rate of change of angular velocity is called angular acceleration. And also we can take the instantaneous is nothing but simply d omega by dt. If we are taking that the SI unit you are getting simply radian per second square. Radian per second square. This is the angular acceleration. The acceleration of the particle. Angular acceleration means simply the rate of change of angular velocity. The relation between angular and as well as linear components. What are angular components? What are linear components means? So here we are taking relation between angular and linear components. So what are the angular components? Angular components are nothing but angular displacement, angular velocity, angular acceleration. Linear components are nothing but linear displacement, linear velocity and linear acceleration. What is the relation between them? Let's see the relation. So here I am considering a particle is moving along the circumference of the circle of radius r, and which can complete the circular path, the position from here to here, and which making an angle theta, and the angular displacement or the arc length is s. Now applying the formula of angle. Angle is equal to simply arc length upon radius. Arc length upon radius. So angle we are writing as theta, arc length s upon r. So then s is equal to what we can able to write, theta r. So this is linear displacement is equal to angular displacement into radius. And also if you are writing the vector notation for this, that we can able to write simply theta cross r bar. Theta bar cross r bar. This is the simply the vector notation by using of right hand screw law. Screw. So while we are trying, you have to make it loose and you have to rotate in clockwise direction. You have to make it tight. You have to use like this. So see here. And next you can differentiate this equation with respect to time on both sides. Differentiate the equation on both sides with respect to time. If you are differentiating that becomes as ds by dt is equal to d by dt of r theta. D by dt of r theta. So ds by dt, rate of change of displacement, nothing but velocity, and r is a radius. If you are keeping constant, then that's we are taking as d theta by dt, differentiation of theta, d theta by dt. So then v is equal to, you are getting r omega. If you are writing the vector notation for that, v bar is equal to omega bar cross r bar. So this is also from right hand thumb rule. So v bar is equal to omega bar cross r bar. This is linear displacement and angular displacement relation. Linear velocity and angular velocity. So next we will write the relation between angular acceleration and linear acceleration. So nothing but again you can differentiate the equation on both sides with respect to time. If you differentiate the equation both sides with respect to time, then you are getting, so dv by dt is equal to simply d by dt of r omega. D by dt of r omega. So here dv by dt, generally you are getting acceleration, is equal to r omega. Means we can take, you can apply the rule of product rule, differentiation, r into d omega by dt plus omega into dr upon dt. So actually this is applicable for only the acceleration, means we have to take uniform circular motion, non-uniform circular motion. From here you can segregate that is the motion is uniform or the motion is non-uniform. Okay, let's see here. Have a look here what we can able to write. This is the total acceleration r into this we can write as alpha. And this is the velocity omega, and this we can take radial velocity, the velocity along the radius, that we can take as radial velocity. This is also we can able to write the expression A is equal to A theta plus AC, AT plus AC. AT stands for tangential acceleration, AC stands for centripetal acceleration or radial acceleration. Centripetal acceleration or radial acceleration. So here it is not always constant, it can be changed by changing the motion of the particle. How it will be changes. So see here, for example, this is simply you can remember this relation between displacement, linear displacement, angular displacement, linear velocity, angular velocity, and accelerations. But here we are getting different expressions. So this is tangential acceleration, this is centripetal acceleration, this is linear acceleration. So this is a little bit confused. So we'll resolve the confusion. If the motion is uniform circular motion, So uniform circular motion, nothing but, what is the meaning of uniform? Uniform is same or constant. So uniform circular motion is nothing but the motion of a particle remains constant, or the speed remains constant. So in uniform circular motion means simply you can give the heading uniform circular motion. Uniform circular motion. Uniform circular motion says that a particle is moving along the circular path with constant speed. Speed constant. Then what about the velocity? Velocity continuously changes here. Speed constant. So that's why here you can take here the direction of the velocity changes. So that's why here the tangential velocity, the magnitude of the tangential velocity is not existing. Magnitude of the velocity constant, but direction of the velocity changes. We are taking only magnitudinally. So in the uniform circular motion, if a particle is moving along the circular path, the acceleration of the particle acting towards the center, that acceleration we can call as centripetal acceleration. So the centripetal acceleration equation we are giving simply omega cross or omega into dr by dt. Omega into dr by dt. The dr by dt is called radial velocity. Then omega bar cross v bar you can write. And also if we are simplifying this expression, omega is equal, you can able to take v by r into v. So the total equation will be goes to v square upon r. Centripetal acceleration v square upon r, or else the centripetal acceleration here in place of v, if you are writing r omega, then omega into r omega, the value is omega square r. The centripetal acceleration v square by r or omega square r. So this is centripetal acceleration. This is a possibility in circular motion, especially in uniform circular motion. And comes to non-uniform circular motion. Non-uniform circular motion. What is non-uniform circular motion? Non-uniform circular motion means the particle is moving along the circular path with variable speed. When the particle is moving with the variable speed, so then what is happening? See here. So one thing, the acceleration is acting towards the center, that is centripetal acceleration. The acceleration is acting along the tangential, that is called tangential acceleration. In this there is no tangential acceleration, but in this the tangential acceleration is there. Then the resultant acceleration is this, and the resultant acceleration may be making an angle alpha with this. So now if you are writing the resultant acceleration in the form of that, so A is equal to what we can able to take? AT plus AC. So in the form of vector notation. If you are finding the magnitude of the resultant acceleration is equal to under root AT square plus AC square. So the magnitude value AT is nothing but R alpha whole square, AC V square by R whole square, v square by r whole square. Like that we can able to take the total acceleration in case of non-uniform circular motion. And what about the direction? Direction there is making an angle alpha. Tan alpha is equal to means you can observe here that is giving a small angle like this. And this is centripetal and this is AT. So tan alpha opposite AT upon AC means tangential acceleration upon centripetal acceleration. Then alpha is equal to the direction alpha is equal to tan inverse of AT upon AC. So this is only possibility in non-uniform circular motion, because in uniform circular motion only we have centripetal acceleration. So let's see, here we are taking the different motions here. Different motions how we are taking. So now only just we saw that uniform circular motion and non-uniform circular motion. So take that. I am simply taking UCM, uniform circular motion, non-UCM, non-uniform circular motion, and UTM, uniform translatory motion, non-UTM, non-uniform translatory motion. Okay, first of all, you can take uniform circular motion. In uniform circular motion, the tangential acceleration is zero. Tangential acceleration is zero because the magnitude of the speed remains constant. So that's why tangential acceleration is zero. And centripetal acceleration is not equal to zero in uniform circular motion. Comes to the translatory, uniform translatory motion. Uniform, nothing but speed constant. Translational, nothing but straight line. So that's why tangential acceleration zero. Uniform, because of that tangential zero. Translatory motion. In translatory motion, what about the circular? What about the centripetal acceleration? Zero. In translatory motion, centripetal acceleration is zero. And non-uniform circular motion, non-uniform, that's why AT not equal to 0. Circular motion, so that's why AT not equal to 0. Non-uniform, AT not equal to 0. Translatory motion, so that's why centripetal acceleration 0. So in translatory motion there is no centripetal acceleration. There is no centripetal acceleration. In uniform motion there is no translatory acceleration. In uniform motion, there is no tangential acceleration. In translatory motion, there is no centripetal acceleration. That is simply about the types of acceleration. Okay, we'll see that in the uniform and non-uniform circular motion only different cases. If the motion is accelerated circular motion, in this condition, the angle between the velocity and as well as tangential acceleration is acute, is nothing but, or parallel also we can say that, acute angle. So here tangential and as well as velocity both are parallel to each other, or else the angle between them may be less than 90, acute angle. In case if you are taking a retardation circular motion, retardation circular motion. In this retardation circular motion, what is happening? The velocity direction is like this, and then tangential acceleration direction is this. So then here tangential acceleration and retardation both are opposite to each other, means anti-parallel. AT and V or anti-parallel, or else anti-parallel, or what we can say that theta is greater than 90, or obtuse angle. So this is simply two conditions. In case of uniform circular motion, there is no tangential acceleration. So we'll move to. Okay students, now we'll solve some problems based on the circular motion. Up to now what we discussed in the previous session. So see here, there is a problem. A particle moves in a circle of radius 0.5 meters at a speed of that uniformly increases. Find the angular acceleration of the particle if its speed changes from 2 meter per second to 4 meter per second in 4 seconds. So what is given? So here particle is moving in a circular path. The circular path of radius is given as 0.5 meters. 0.5 meters. And speed is gradually increasing. And they are asking about the acceleration. Which acceleration? Tangential acceleration. And angular acceleration. But indirectly they are giving the tangential acceleration. Let's see what is the tangential acceleration. Tangential acceleration, nothing but what we are writing. The tangential acceleration is change in velocity. Tangential acceleration equal to dv by dt. Change in velocity. What is the change in velocity? 4 minus 2 in how much time? 4 seconds. Change in velocity upon time. So now what is the tangential acceleration? The tangential acceleration is 2 by 4, nothing but 1 by 2 meter per second square. This is the tangential acceleration. Then what is the angular acceleration? You know that you have radius, you know tangential acceleration. Then you need to take here simply the tangential acceleration at is equal to, you know the formula, r alpha. So then alpha is equal to simply at upon r. So the value of r is 0.5 and this value also 1 by 2 means 0.5. So 0.5 upon 0.5, that is 1 radian per second square. The angular acceleration of the particle is 1 radian per second square. This is the simply angular acceleration. We'll move to the next problem. What is the next problem? The speed of the particle moving in a circle of radius 2 meters. Circle of radius is 2 meters. Varies with the time t as a function of time, that is given as v is equal to t square. This is the given value. V is equal to t square. Then find AR. AR stands for radial acceleration or centripetal acceleration. Next AT. AT stands for tangential acceleration and also net acceleration at a time of 2 seconds. First of all, we'll try to get what is AR. First of all, what is velocity at 2 seconds? So you can take here AR is nothing but v square upon r, which is at 2 seconds. At 2 seconds means you can take velocity at 2 seconds, that is equal to v square. V is equal to how much they have mentioned? T square. Nothing but t is 2 seconds. So that is equal to 4. V is equal to 4 meter per second. Now the tangential acceleration, radial acceleration goes to AR is equal to how much? 4 square upon r value 2. 4 square 16 by 2, that is 8 meter per second square. 8 meter per second square, that is the radial acceleration. Then try to get the tangential acceleration. The tangential acceleration is A is equal to dv by dt. So then d by dt of v is nothing but simply t square. Differentiation of t square. Differentiation of t square is nothing but 2t. Differentiation of t square is 2t. It is at what time? At t is equal to 2 seconds. At t is equal to 2 seconds. Simply substitute the value of the 2 seconds. So then the value goes to us A is equal to 2 into 2, that is 4 meter per second square. This is 4 meter per second square. Here 8 meter per second square and 4 meter per second square. This is the tangential value. Now we have to take the total acceleration or the net acceleration. Net acceleration, you know the formula, under root at square plus ar square. So at square means nothing but tangential acceleration square. 4 square plus ar square, 8 square. So that is equal to 4 square 16, a square 64. That is root 80 meter per second square. Root 80 meter per second square. So this is radial acceleration or centripetal acceleration. This is tangential acceleration, and this is net acceleration. So let's we have one more problem based on the net acceleration. See, the problem is here. The particle moves along the circle with a speed of v is equal to kt, means variable speed. V is equal to kt, where k is equal to 0.5 meter per second square. Find the net acceleration of the point at the moment when it has covered the nth fraction of the circle, means the particle is moving which covered nth fraction of the circle, after beginning of the motion, and where n is equal to, they are giving 1 by 10, means it can cover the distance in the total circumference 1 by nth fraction or 1 by 10th fraction. So very simple question here. First of all, so they are giving, you try to get the how much distance that is traveled. For that I am taking v is equal to ds by dt. So then ds is equal to simply v dt. What is the value of v? Just substitute. So if you are substituting the value of v, then ds is equal to kt dt. Then integrate on both sides. Integral ds, yes, integral k into integral t square, integral t dt is nothing but t square by 2. So the displacement is half k t square. The displacement is simply half kt square. So this is actually how much the distance which is traveled, this much distance, 2 pi r by 10, nth fraction. How much fraction? 2 pi r by n also you can take, no problem. 2 pi r by 2 pi r into n you have to take. If you are taking by n, that's wrong. So now substitute the value of s. The value of s is half k t square is equal to 2 pi r n. Just I want the value of time, so that I am taking t square is equal to, the value is 4 pi r n upon k. 2 2s are 4 pi r n upon k, that is t square. Let's try to get means net acceleration, means which is the combination of translational and also angular, means the tangential acceleration and also angular acceleration required. For that I'm writing the tangential acceleration is simply dv by dt. What is the value of v? V is equal to kt. Just put it, d by dt of kt. So k is constant and differentiation of t is 1. So then tangential acceleration is equal to simply k meter per second square. K meter per second square. Now move to the centripetal acceleration. The centripetal acceleration is equal to simply what we can able to take, a r is equal to v square upon r. Just v square value, you can substitute the value of v square. What is v square? V square is equal to k square t square upon r. Now put the value of t square. What is the value of t square? The value of t square is 4 pi r n by k. Just put it. So k square by r into t square. How much? 4 pi r n upon k. K cancel. R also cancel. Then the value of AR is what you have, 4 pi n k. The value of R is 4 pi n k. You know that. What are the values of k? So first AT is equal to, the value of k is 0.5, means the value of AT is equal to 0.5 meter per second. And what is the value of AR? The value of AR is 4 pi n into k. Just put the value of 4 into pi value 3.14, n value 1 by 10 into 0.5. So just simplify this. How much you are getting? Let's see. AR is equal to Here what is the possibility? I am writing it as 1 by 2. 2 to cancel, and this is 5. So the value is simply 3.14 upon 5. 3.14 upon 5 means nearly how much you are getting? 0.61 nearly, and that is 0.5. Now the net acceleration is equal to under root at square plus ar square. The value of net acceleration at 0.5 whole square plus ar 0.6 whole square. 0.5 whole square means 0.25. 0.6 whole square 0.36. So 0.25 plus 0.36. The value is, total value is 0.61. 0.61. 0.61 means around you are getting 0.78 meter per second square. That is the net acceleration.